Good afternoon, everyone. In today's world, companies want to evolve their platform. Basically, the companies who want to evolve into a platform are facing three types of challenges. One, having their developers seamlessly integrate into their service. Two, being able to address the scalability to meet the fluctuating demands of their developers. And three, provide real-time updates to ensure that data flows seamlessly without a lag. Hi everyone, my name is Ojus Save, and in today's session we will learn how event-driven architecture can help your platform address these challenges by enhancing, improving scalability, and providing real-time updates. A little bit about me before we begin. I am the lead developer advocate at Zoom. My background includes time with Google's Dialogflow team and an API startup called Neura. I am here to share my insights on basically making your developer experiences better. My main areas of focus at Zoom are, of course, our event-driven services, which is Webhooks, WebSockets, our chat platform, our marketplace app build flow experience, and the GraphQL APIs. This is a quick safe harbor statement from Zoom that they have asked me to put. Basically, our session today should not, basically whatever we talk about Zoom today is only for description, like informational purposes, and should not influence you to make any purchase decisions. Here is what our agenda looks like. I will start by explaining the event-driven architecture, its core components, and why it is beneficial over the traditional API-based architecture. We will then take a look at event consumers, focusing on webhooks and WebSockets. Then we will see a case study of the Zoom developer platform, of course, specifically focusing on the role that our event-driven services play on our Zoom developer platform. We will also see how easy it is to get real-time data from Zoom using both our webhooks and WebSockets. And I would love for you guys to sit and build with me. So all you guys need is a Zoom client installed in your system, which I'm assuming probably everyone has, and Postman if you want to test WebSockets with me. Once we are done with the demo and everyone's done building on Zoom, we will then discuss the benefits of adopting event-driven architecture on your platform, share best practices, address some of the challenges with event-driven architecture, and then conclude with key takeaways from our today's session. At the end, I will also, if we have time, I'll open some time for questions and answers if you guys have any. So before we begin, I'd like to show you a quick thing. So assume I want to get real-time data of what's happening from like a platform. Traditionally, what I would do is make API calls. Oh, of course, there is no message, sorry. So I make a request, and if there is like data, then I will see the data every time I make a request. This is the traditional API-based architecture. In this slide, we can see the outline limitations of the API-based architecture. Basically, it highlights the critical challenges that platforms face, such as increased server load. Like imagine there are a number of people making simultaneous API calls on your platform. Difficulties in managing high throughput scenarios, complexity for consumers in dealing with polling, rate limits, higher operational costs from managing extensive APIs. Like the API call that I was making was just like normal data. But imagine if you want to give someone like real-time dashboard analytics. Managing all of that with the API-based architecture can be challenging. Basically, all of the challenges that I've mentioned here underscore the need for more efficient and scalable solutions like event-driven architecture to address the evolving demands of the digital ecosystem. So what is event-driven architecture? Event-driven architecture is a design paradigm where software components react to events. Let me give you an example. I had a presentation today, and for that I had to wake up at 6 a.m. If this was a traditional API-based architecture, what I would do is I would try to wake up, like, let's say every hour and see, oh, is it 6 a.m.? No, go back to sleep. Is it 6 a.m.? Or no, go back to sleep. Now, to be honest, it's inefficient and it's exhausting. Instead, the ideal thing to do is set an alarm for 6 o'clock. So I don't need to know whether it's 6 a.m. or not. If it's 6 a.m., the alarm will go on. That's exactly what EDA in action looks like. Software components don't constantly need to check with each other. They simply react when an event occurs, such as, again, when it's 6 a.m., the event is triggered. This approach not only reduces the workload, but also enhances system scalability and flexibility. It's a game changer for real-time applications, from instant messaging to live data updates, where immediate response to events is crucial. Event-driven architecture, or sometimes what I may say as EDA, creates a system that is more responsive, efficient, and adaptable, revolutionizing the way we think about software interaction. If you're planning to implement event-driven architecture, then you need to know its three core components. One is the event producers, second is the event brokers, and third is the event consumers. Take this architecture as an example. The event producers, as the name suggests, produce the events, and the consumer, as the consumers, as the name suggests, consume the events. Like basically, whenever the event happens, the consumers decide what to do once they receive the events. The event brokers are the ones who manage the events through like message queues and send the events from like event brokers to from the event producers to the event consumers so that they can react in real time. Now, what are the advantages of event-driven architecture over traditional API-based frameworks? What is scalability and efficiency? So imagine that you're a stock trading platform and you want, like, your user sets a limit to sell a stock at a certain price. You don't want it constantly be polling and seeing, especially in the stock market, where the prices can sometimes fluctuate between seconds. You don't want to constantly poll and see if the stock has reached that price. Instead, you can use event-driven architecture to automatically execute the order once the price has reached. This not only makes the process efficient, but also ensures that the platform can scale and handle high volume of such transactions simultaneously. The second one is flexibility and adaptability. Consider a delivery service platform where you want to constantly update all your parties about your order progress, delivery times, and changes. Implementing EDA can showcase the flexibility and adaptability of your platform to handle dynamic scenarios efficiently. Real-time responsiveness and fault tolerance. Imagine your user is hosting a virtual meeting and their IT team wants to monitor in real time if there are any issues in the meeting. Instead of, again, them constantly polling to get that real-time data and causing a huge load on your servers, what you can do is notify them in real time, which ensures swift resolution and maintaining seamless communication in any case that an issue occurs. The last one is system resilience. So imagine, I'm assuming all of us have used smart devices before in your home. So we have like the smart cameras, we have our hubs, we have our thermostats. So in essence, imagine like if one system fails, you still want your whole IoT platform to not crash. So EDA does handle system resilience properly. Moving on to event consumers. Event consumers are unsung heroes in our systems. They automatically respond to events, keeping everything running smoothly without needing us to step in. They keep an eye on the pulse of event streams, ready to spring into action, ensuring our systems are scalable, responsive in real time. So now, assume you are a platform and you want to notify your users in real time. You can do that in like multiple ways, but the two ways that we are going to explore today are webhooks and websockets. So webhooks and WebSockets are basically two different types of communications. Webhooks are unidirectional and mainly used for server-to-server communication. Webhooks require an endpoint. So basically, like if you have a third-party developer, they would give you an endpoint, and then whenever an update occurs on your end, you would send a real-time notification on that endpoint. Webhooks are stateless, meaning each request is independent of the other request. And on the other hand, WebSockets are bidirectional. They have a server-to-browser or a server-to-client interaction type. They do not require a predefined endpoint. When we go to our demo, we will see that in Zoom, if a developer wants to use a WebSocket, they do not need to provide us with an endpoint. Instead, we provide them with an endpoint where they can open a connection, and we send them data in real time. Moving on to our case study, Zoom video communications. So, let me ask you a question. Who over here has used Zoom before? All right. Who over here thinks that Zoom is just a video communication platform? Like just meetings, there's nothing else on Zoom except for meetings. All right, good number. Well, let me tell you, Zoom is not just limited to video conferencing. It's a comprehensive unified communications platform, seamlessly integrating team chat, Zoom phone, contact center, whiteboard, workspace reservation, and AI companion. We are all about revolutionizing how we communicate, collaborate, and connect in today's digital world. Moving on to the next question. Who over here has used the Zoom developer platform? All right. Well, if you have used Zoom before, there is a high chance that you have interacted with that developer platform. If you have if you have scheduled a meeting through your calendar, you have interacted with that Zoom developer platform. The Zoom developer platform is an open platform that allows third-party developers to build applications and integrations on Zoom's unified communication platform. So, what is the purpose of implementing event-driven architecture on Zoom developer platform? We have developers who need real-time data to create responsive and dynamic applications. In this context, the event-driven architecture on Zoom developer platform plays a very important role. Event-driven architecture, or our event-driven services, enable us to efficiently manage increased load and support a growing user base without compromising performance. It ensures that any service disruption has minimal impact, keeping our platform reliable for developers and users alike. Our event-driven services enhance our operational efficiency, allowing us to utilize resources that are more effective by activating services only in the response to specific events. Furthermore, we are able to innovate on the forefront of communications technology. It helps us to be ahead in the competitive landscape, while fostering an environment where the developers can thrive and build cutting-edge solutions. Enough of the talk. Let's move on to the real demo. So, for demo purposes, since a lot of you are not familiar with Zoom Teams chat, we're going to use Zoom Teams chat to receive event notifications in real time. So what you want to do is, again, let me go back to this. Bring this here, and again I'm going to show you the example. So I want to be notified every time, like I want to check if there is like a message sent by my user. Like right now there is hi. Let's see if there is another message sent. Hello. Well, I don't know if there's a message sent, so what I'll have to do is check. Alright, there is a new message sent. So every time I need to know whether there is like an update, I have to constantly poll from the service. Instead of that, what I'm going to do is I'm just going to build an event notifier wherein I can receive the responses in real time. So if you're building with me, go to marketplace.zoom.us, click on develop, and click on build a server-to-server app. Now, if you want to talk about our app types, that would be a totally different session. So just for now, focus on building a server-to-server app. Let's call this test app. Hit create. Once you create an app, it gives you account ID, client secret. For today, for right now, we're not going to look at it. We're going to go to the features section, enable event subscription, click on add event subscription, and let's name it test event. For now, because for our first demo, we'll select the type as webhook. And then now it's going to ask you to provide like an endpoint URL. For testing purposes, I've built this site. Go to ojus.ngrok.dev and then select default authentication. It will ask you to input a secret token. And why we do that, we'll go over that later. When we see like how you want to build your event-driven services. So copy the secret token, paste it here, and it will give you an endpoint. Grab that endpoint. Sorry. Go here. Paste it here. So what we do at Zoom is every time someone wants to build like a webhook integration, we require them to validate their endpoint. Why validate their endpoint? So we have like third-party webhook endpoint services like Webhooks. What used to happen is people used to provide us with their endpoint URLs and then just forget about the app. Now, if it's a single user, that's okay, but imagine a big customer where it has like 10,000 users and they selected an event where it says notify me every single time a user starts a meeting in my account. Imagine handling those events and trying to send them to an endpoint that is no longer in function. You know, that's another topic of scalability issues. So hit validate and the endpoint is validated. So now what happened is, now that the endpoint is validated, Zoom will start sending events in real time. Now let's click on add events. Because we're going to test our chat platform, let's select our chat events in real time. I'm having a very hard time. User webinar recording within contact center. You know what? We're just going to look at meeting events. My bad. So we want to be notified every time a meeting has been created, updated, and deleted on my platform. Hit done. Hit save. So this is the endpoint. And right now what I'm going to do is I'm going to go to my Zoom.us account. Sorry, bear with me. Go to my account. And I want to be basically, I want to know every time a meeting is scheduled or like created in my account. So I'm going to go ahead and create a meeting. It should have popped up there. 100 times, but once you do the demo, it doesn't work. Sorry about that. Let's see what might have happened. Let's look at the logs. Well, it should send the events. Let me go back to the app configuration. I must have done something wrong here. Of course I did it. I didn't do the whole thing. Continue. See. Test. 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 Ojus Save. Alright. Now. Hopefully now we should be able to see the events in real time. Let's try to schedule a meeting again. Save. And there it is. See, as soon as I scheduled the meeting, I was able to get the payload in real time. Hit delete. I'm going to delete the meeting now. And you can see that I was able to do this in real time. Now assume over here I was calling the meeting API and not the chat API. In order to get that data, I would have to constantly poll. Same with WebSockets. So what we want to do over at Zoom is, we want to empower our developers. We want to give them more options to build their integration seamlessly. So sometimes we have developers who are like, well, we're providing you with an endpoint, but what if it's not secure? So if you go on our webhook documentation, you can see that we have various authentication methods in webhook. So for example, go back here, you can, right now what I did was just like use the secret token, but if the developer is like, hey, I want to know, like I've provided you with my endpoint, but I want to know whether the events are indeed coming from Zoom. So we have basic authentication where basically the user can create a username and password. Let's say in this case, test, and then again provide a secret token. Now again, this is something I have built at my end. If you want to build like your front end, you want to build it more user friendly, but yeah, so now I'm going to go here, I'm going to delete this one, and I'm going to build another event subscription. We'll call it test2, okay, our username and password is test, okay, perfect. URL here. Validate. Oh, it validated. But then, in order to receive the events, what I want to do is we have different authentication types. So in basic, I'm going to add this as test. Password is test, and add events. Meeting. So meeting created, updated, deleted, done, save, continue. Oh. Yeah, it's going to ask me to validate it again. Now again, on our backend, it sometimes takes up to 5 minutes for the endpoint URL to be updated. So let's see. Right. Give it a couple of minutes. As I said, it takes up to like 10 minutes sometimes if you are updating an existing endpoint for it to show. But you get the gist. What I'm trying to do here is I have a developer who's like, yeah, we want to make sure that the events are indeed coming from Zoom. So they can provide their own username and password and implement basic authentication on their end. And at the end of the day, they can check, okay, is the value, like the base64 encoded value, similar to our client ID and client secret, or like the user ID and password that we earlier provided. But then we still have developers who are like, no, we just don't want to build an endpoint. This happens a lot with fintech customers. And for them, what we did was, okay, we still don't want them to poll in real time, like, because it's going to cause like a huge load on our servers. So we decided to provide them with a totally different alternative, which was WebSockets. So as we said, WebSockets theoretically is like a bidirectional communication method. What you do is you click on add an event subscription. Again, we'll call it new WebSocket. Click on WebSocket. See, now you don't have to provide the endpoint URL anymore. Click on add event. We're probably going to listen to the saved events. Meeting has been created, updated, and deleted. It's done. It's saved. Now, what happens is, instead of you providing Zoom with an endpoint URL, Zoom will provide you endpoint URL. Hit copy. To demonstrate WebSockets, I'm going to use Postman. So the first step is to build a new request, and then you want to select WebSocket request. Just paste the endpoint URL as it is, and then you want to, sorry, let me just write it here. It'll be much easier for me. All right. Yeah. All right. So what you want to do is just paste the endpoint URL that Zoom provided you as is. It'll by default load your subscription ID in Postman, and then you want to append your access token. How to get that access token? So you remember we created an app, the server-to-server OAuth app type. So go there in your app credentials section and grab these three credentials, and you want to generate an access token. So paste your account ID, your client ID, and your client secret. Hit send, and it generated an access token. Grab this access token, paste it here, hit connect. What will happen now is there is this connection which is open between the client and the server, and this connection is open for 1 minute. So whatever conversations or like whatever events get processed in this 1 minute, we will be able to see it here in real time. Now, what happens if I want to keep this connection open? I will send a message called module heartbeat. Again. Send. So now every time we receive this message, the connection will be open for 1 more minute. Now let's check our services in action. So I created a meeting, and you can see that I received this payload in real time without having to make any API calls. So yeah, that's it. about our webhooks and websockets. So, what are the benefits of adopting EDA into your platform? Basically, by integrating event-driven architecture, you can fundamentally shift how the system operates, integrates, interacts, and that optimizes it for real-time responsiveness and scalability. This transition allows dynamic expansion of the platform's capabilities by easing integration of third-party services. Essentially, event-driven architecture enables your platform to adapt and evolve without heavy lifting, which is traditionally required for new feature development. The magic of EDA or event-driven architecture lies in its approach to basically resource allocation. Unlike traditional architectures that might constantly consume resources, as we earlier saw, like in order to get the data, I have to constantly pull from the server. EDA's nature ensures that resources are utilized only when necessary. This not only boosts the operational efficiency, but also significantly reduces overhead in paving the way for more sustainable growth and development practices. Basically, it's like event-driven architecture translates into more scalable, efficient, and innovative platform capable of meeting the demands of today's fast-paced tech environment. Best practices for implementing EDA. So, one of the main concerns that your developers or your end users might have if they are using EDA is, am I getting the same data that I would get through an API call? So you want to make sure that the way you design your events in your domain is crucial. That means you want to specify exactly what every event does. Let's go back here. Let's see this. Meeting created. It basically would provide me the same payload that a user would get if they had called our meeting APIs. Secondly, scalability is the key. So you want to make sure that asynchronous communication is there and your system is able to handle loads without breaking. So to give you an example, let's say we have one service that is trying to get these events. It's easy, but let's say if you have like 10 or 15 different services listening to the same event, how are you able to do that? It's very important. Then you want to make sure that idempotency and order management is also implemented. Like for example, if I have a user who's listening to the meeting created, participant joined, participant left, and meeting ended events, I want to make sure that those events are sent in a serial manner. Sometimes mistakes happen, because of server load or some backend issues. Your events don't get delivered in the chronological order that your end user is, basically expecting. What you can do is, the best thing to do is implement the event timestamp, so that even if they are not delivered, you want to really make sure that it's delivered in a chronological order. But even if not, then it's easier for the user to identify which events should have happened when. Then you want to make sure that there is robust error happening. This is something that I really like what we do over at Zoom. What we do is, we want to make sure that whenever an event happens and you're subscribed to that event, it's delivered in real time. But for some reason, let's say your endpoint is not working, we have implemented a retry logic. So we have a retry in, I want to say 3 minutes, 5 minutes, and 15 minutes, or 5 minutes, 15 minutes, and 1 hour, something like that. So we try to see whether, if you do not receive the event in the first try, then we try second time, and then we try the third time. We also try, we also want to make sure that, you're not, as I said earlier, you're just not providing endpoints to us and then forgetting about it. So we also require you to revalidate this endpoint every 72 hours. So incorporating practices like this in your event-driven design does not only optimize your architecture, but also paves way for new innovative feature development. last one. So while event-driven architecture is amazing, there are some cases where it might not be the ideal fit. Like for example, if you need immediate data access, like I want to know what's happening in my account right now. Event-driven services are only fired when an event occurs. So in this case, APIs are a good use case. Second is point-to-point integrations or stateless operations, or if you have like simple architectures. Let's say I just want to make a call and get the data right now. In that case, you don't really want to, like if you don't have a complex architecture, you don't want to implement the event-driven architecture in your own code. Like I'm talking this from the perspective of a developer, not as a platform. Last slide. What are the key takeaways from the session? So we've learned so far that event-driven architecture is not just an architectural choice, but you can say it's like a backbone of the next generation event developer ecosystem. It empowers systems with real-time responsiveness, crucial for applications demanding immediate data processing and interaction, ranging from like financial services to like communication platforms. By decoupling system components, event-driven architecture fosters a modular architecture where services communicate through events and not direct calls. This separation enhances the maintainability and scalability of the systems, allowing developers to innovate and iterate rapidly without being bogged down by complexities of tightly coupled components. The operational efficiency gained through the dynamic resource allocation in event-driven architecture, again, was stated. It ensures that the resources are utilized only when necessary, optimizing cost and performances across the developer platform. This is especially relevant in cloud-native environments when an efficient use of computing resources directly translates to operational savings. So yeah, if you decide to implement event-driven architecture on your platform, you're basically making a strategic move towards building more efficient and future-ready platforms. Any questions? Wow. You know, when I was in school, my professor would tell me, if there are no questions, either people understood everything or people understood nothing. All right, yes.
So, how do you take care of sequencing your agents?
How do we take care of?
The sequencing your agents.
So we have a message queue. I can't really tell what we use in the backend, but we have a message queue. So every time like an event occurs, it is sent first to that message queue, which is kind of, you can call it as an event broker. And then in the order that we receive the events, we kind of fire it to the end user.
Yeah, so in such cases, right, like there could be a discrepancy or the way the events are going to be in a different sequence, right? Like for example, you're sending an event to create a meeting and then immediately cancel a meeting, right? Instead of like canceling, like I'm updating a meeting and then canceling.
Right.
So when the sequence reverses, when you create a meeting, you cancel a meeting and then update a meeting, right? How do you take care of the sequencing part, right? Like your producers can be multiple services running in your environment.
Good question. So the way it would work with Zoom is if you create a meeting and then you delete it, you can't update it.
No, like you update it in between,
right?
And then you delete the meeting, right? But the message received by the broker has received delete first, and then the update comes the next, right? Like there is a sequencing, right? Like do you take care?
So in very rare cases, this has happened with us. I don't have like an ideal answer, but what we do is we provide a timestamp. So if the end user receives, like it has happened in multiple cases, like you know, we've had the meeting created event and then you get or sometimes like it's like meeting started. Ideally, you should receive the meeting started, then the participant joined, but there are cases where you receive the participant join and then you've received the meeting created event. But then we've also provided timestamps. So in that case, you know, we've just asked our end users to follow those timestamps to know like which event should have occurred first.
So the To just add to that question, the timestamping that means is the event timestamp and not the broker timestamp, right?
The event timestamp, yes.
I have one more question, Ojus. So you basically mentioned about like the retries, which is like every 5 minutes and 10 minutes and then maybe half an hour. In general, a lot of applications may require it in such a way that either you give me and you retry fast because once 5 minutes expires, my window kind of expires. So what are your thoughts on either retrying it faster or not sending it at all?
Again, it depends. In our cases, what we have seen is like the reason why we do retry is to like sometimes the user's endpoint may not be functioning. So if it's down, we kind of like I think the idea behind building the 5 minute or 15 minute retry was that the endpoint might not immediately start working in like the next 15-20 seconds. So you want to give them some time to make sure like that endpoint is again functioning and they're able to receive the events. Yeah, and then again at such times we also recommend our developers that they sometimes just make like API calls in the backend to make sure that the data is up to date or not. Any other questions? Yes.
I would say, since I'm more product focused and I work with a lot of our engineers to kind of think from the event perspective, especially if we work more with like Dynamo, with a lot of data. When it comes to like events versus like API calls, how have you kind of measured or measured what makes more sense in those scenarios?
I really wanted to show the numbers today. I was just not, they did not allow me to show the numbers. But I can tell you that we have been able to scale our systems more efficiently by implementing event-driven services. Let me give an example. So what we were looking at right now was just like created, updated, deleted events. Now, even if someone were to make those API calls, those would be like very light API calls. But we have customers who rely on heavy dashboard data. Like we want to know if there's an issue in the meeting. We want to know what, and again, all of this data is provided to you on Zoom dashboard. But providing that data in, like imagine someone making those API calls constantly to get that data. And again, it's not just one meeting. Imagine a big customer with 10,000 users. You have 500 meetings happening at the same time. We can't afford those 500 API calls coming on our server to get that dashboard data in real time. So in this case, like we have implemented our quality of service webhooks, wherein we send you that dashboard data in real time, and that's like a very heavy data that we send you. And yeah, that basically it has kept our servers, like not like basically servers don't crash because of that in real time. Yeah.
Okay, so you would say like a way that you guys can track like the metrics for that is whether or not you're having less server load. Would you say that also a good practice would be to kind of test like different scenarios in which like you have had issues with different APIs with events to make sense if it makes, like from a leadership perspective, if we should do the development to move into other areas?
So that's a good question. At the end of the day, as a developer advocate, what I always like to do is I like to see how our developers want to utilize our platform. So if there is a use case in your platform where your developers need real-time data, then I want to say it's like a no-brainer. Like you should implement event-driven services. Alright. Sounds good. If you guys have any more questions, you can feel free to connect with me on LinkedIn or follow me on Twitter. And yeah, happy to answer any questions that you guys might have. Thank you so much.